Good morning. It's John Gilkison, AeroStealth here. It is Tuesday, February 28th, 2023, and I wanted to shoot a quick video this morning on propane stoves versus induction stoves cost per effective therm. Now, it may sound a little bit obscure, but I've seen others do comparisons on gas versus induction cooking, and they claim that induction cooking is 95% efficient because the act of induction heats just the pan, and then the pan heats the food, whereas with a gas stove or a propane stove or even an electric stove with a coil element, the heat goes around the pan as well as heating the pan. So they claim that gas stoves, propane stoves, and even electric stoves are only about 45% efficient. So one of the things that's caught my attention was the fact that they gave the cost per therm, and they never really translated this efficiency into the cost per therm, which I call the effective cost. So I wanted to give you I've written this up real briefly here, give you a chance to study this a little bit. Now, the important points in this document are, number one, is the therm is 100,000 BTUs, and a BTU is, of course, is the amount of heat it takes to heat 1 pound of water 1 degree Fahrenheit. So it's a British thermal unit. There's 91,500 BTUs in a gallon of propane. Now, I don't have natural gas at my house, so I didn't do anything on it. But you can do the math for natural gas yourself if you have it. But for electricity, there's 3,412 BTUs in a kilowatt hour. So the first thing you really want to do is divide both of these figures into 100,000 BTUs, or a therm. So 100,000 BTUs divided by 91,500 gives you a multiplier of 1.09 for propane. But with electricity, straight out of the wire, so to speak, 100,000 BTUs divided by 3,412 gives you a multiplier of 29.3. In other words, there's 29.3 kilowatt hours in a therm. So, back to propane. Propane's costing me recently $3.86 a gallon. Last time I took a delivery. And that price varies over time, although slowly. For example, the price, it's kind of linked to the price of gasoline. And the price of gas can drop $1 a gallon, but it'll take quite a few months for propane prices to drop. Don't ask me why that is. So anyway, $3.86 a gallon times 1.09 gives you an effective cost of, or a literal cost, excuse me, of $4.22 for a therm of propane. However, with electricity, we pay 12 cents a kilowatt hour. 12 cents a kilowatt hour times 29.3 gives you $3.52 for a therm. So you can see at current propane prices, a therm of electricity is cheaper, a kilowatt hour therm. So again, they claim propane stoves are 45% efficient, so you have to divide 0.45 into this $4.22 cost per therm, which gives you $9.38 per effective therm. That's the amount of heat that's actually going into your food in the pan, not to heat the air in your house. $9.38 per therm, effective therm, for propane stove, which we have. If we had an induction stove, it is $3.52 per therm divided by 0.95, because induction stoves are 95% efficient, and that equals $3.71. So as you can see, propane's 2 point something. I haven't figured it out yet, but it's less than 3 times as costly per therm as an induction stove would be currently. And this is not even to mention the other attributes an induction stove might have. They're faster, you got more precise control. They don't heat up the room as much. Now, this can get a little confusing, especially on the electrical side. You're going to pay whatever you pay for propane or natural gas, and you'll just have to figure it out. But for electricity, it's really pretty simple. All you really have to do is use a 10-cent a kilowatt hour rate, even though I don't pay that. And when I do that, I get 29.3 times 10, that means it's $2.93 a therm. Now, every other rate, whether it's 11 cents, 12, 15, 16, whatever it is, it's just a multiplier. Let's just say, for example, it's 16 cents a kilowatt hour. Well, then you'd use 1.6 times that $2.93 a therm rate. And that would give you your rate per therm for your rate. And then you would use your divisor 0.95 for the efficiency. So I just back figured the same rate, and that's the bottom line here. Back from 10 cents, see where my finger is? Back from 10 cents to 12 cents to show you how that would work. So for example, $2.93 a therm at 10 cents a kilowatt hour times 1.2 equals $3.52 divided by 0.95 is $3.71, right back to where I was before. But I'm just showing you how it's done. So that's all I have for you today. I really think that I'd love to get an induction stove. It's most inexpensive good one we've found runs around $1,200, and then we'd have to hire an electrician come in because we don't have any 240 volts behind our stove, and we'd have to get a 240 volt circuit added to the house in order to run an induction stove, and I don't know what that would cost offhand, but I'd love to do it. Excuse me. And the same thing, we'd like to have a hybrid or what's called a heat pump water heater installed. And again, that would take a 240 volt circuit installed in our utility closet. Wouldn't need to be as large as it would need to be for the stove. But anyway, that's all I need is a 40-gallon unit. So, AeroStealth signing out here. This is some efficiencies that are on the horizon as we begin to electrify more and more. And when we electrify our homes and our cars, as the grid keeps getting cleaner and cleaner, our energy use can get cleaner and cleaner, as well as with the steps that I'm showing you here. These things are a lot more energy efficient, so you're using less energy. And so that's two of the keys to electrification right there. Have a good day, everybody. Bye-bye.